You know, we see it almost every single night, this constant, silent companion up in our sky. But the story of our moon? Oh, it is far more dramatic, way more violent, and absolutely essential to our existence than you probably imagine. So let's pull back the curtain on this silent partner that literally shaped our world. Just think about that for a second. Yeah, we've got water, we have an atmosphere, we're in that Goldilocks zone from the sun. Perfect. But there is another massive piece of the puzzle, a key ingredient in the recipe for life on Earth that, honestly, often gets overlooked.
That's right, the moon. I mean, without that familiar face in the sky, our planet would be a dramatically different and very likely a completely uninhabitable world. So, how on earth does this giant ball of rock make our life possible? Okay, first things first, let's look at the most profound way the moon affects us every single day. See, it's not just some pretty light in the sky. It's an active partner in Earth's life support system.
It really all comes down to stability. You see, Earth has this natural wobble on its axis, kind of like a spinning top that's starting to slow down. Without the moon's huge gravitational pull, that wobble would be completely chaotic. We'd get these wild, unpredictable swings in our climate. I'm talking glaciers forming in the Sahara. The moon's gravity also pulls on our oceans, creating the tides, a constant rhythm that has guided life for eons. And the reason it has all this power? Well, it's the fifth largest moon in our entire solar system, which gives it the gravitational muscle to hold us steady.
All right, now let's step away from Earth's perspective for a moment and actually take a trip to the moon itself. What is it really like as a physical place? Let's zoom in on this scarred, silent world. To get a sense of scale, let's start with its size. The moon's radius is just over 1,700 kilometers. But, what does a number like that actually mean in comparison to us, here on Earth?
So, this chart really puts that number in perspective. The moon's diameter is less than a third of our own planet's. So even though it totally dominates our night sky, it's actually a much, much smaller world. And here's a pretty wild fact. That distance is actually getting bigger. Thanks to the very same tidal forces that move our oceans, the moon is slowly spiraling away from us at about the same speed your fingernails grow. Get this, it was once 18 times closer than it is today. The environment on the moon is one of brutal extremes. You've got only 1/6 of our gravity, basically no atmosphere for protection, and temperature swings of hundreds of degrees from sunlight to shadow. It is about as alien as a world can get. Right, and that lack of atmosphere means the surface is a perfectly preserved record of cosmic history. It's just covered in craters from billions of years of asteroid and comet impacts. The whole surface is coated in this fine gray dust called regolith, and you know those light and dark patches you see from Earth? Well, the bright areas are the ancient, heavily cratered highlands. The dark areas, which are called Maria, that's Latin for seas, are younger, smoother basins that filled up with lava billions of years ago. So, how was this essential, scarred world even born? Well, its origin story isn't a gentle one. It's a tale of absolute cosmic catastrophe.
The leading theory is just incredible. About 4.5 billion years ago, a planet roughly the size of Mars, which scientists have named Theia, slammed right into a young Earth. The impact was so powerful, it basically vaporized Theia and blasted a huge chunk of Earth's own mantle into space. This cloud of debris was then pulled together by gravity, forming a hot, molten moon that was incredibly close to us. Had the impact angle been just a few degrees different, we might have ended up with a ring system like Saturn, or maybe no moon at all. It took an amazing amount of luck to get the moon we have today.
That violent birth set up this really unique and intricate relationship between Earth and the moon. So let's explore the consequences of that formation, focusing on this grand dance it performs around our planet every single month.
This is one of the most common questions about our celestial neighbor, right? No matter when you look up, you always see the same pattern of craters and Maria. The man in the moon never turns his back on us. So why is that?
The answer is this phenomenon called synchronous rotation, or tidal locking. See, over billions of years, Earth's gravity slowed the moon's rotation down until it perfectly matched its orbital period. It takes about 27 days for the moon to circle the Earth, and it also takes, you guessed it, about 27 days for it to spin once on its axis. And the result of that perfect timing? One side is perpetually locked facing us. Now, this leads to one of the biggest misconceptions in all of astronomy. There is no permanent dark side of the moon. The correct term is the far side. It's not dark, it's just unseen from Earth. I mean, think about a new moon. That's when our sky is dark. That's because the far side is fully lit by the sun, while the side facing us is completely in shadow.
Of course,
The story of the moon isn't just about rocks and orbits. It's also about us. It's been a source of wonder, it's been a destination, and now it's becoming a stepping stone to our future out there in the cosmos.
Our journey to the moon really happened in a flash. We went from the very first grainy images of the far side in 1959 to the first human footsteps just 10 years later with Apollo 11. But then, silence. Now, after a pause of more than 50 years, we're finally planning our return with Artemis 3.
The legacy of that first era of exploration is just immense. Only 12 human beings have ever walked on another world. They brought back over 380 kilograms of lunar samples, a scientific treasure trove that is still to this day revealing secrets about the formation of our solar system.
And this new push to the moon has an even bigger goal in mind. The Artemis program isn't just about repeating the past. It's about building a sustainable presence on the moon. It's about using it as a crucial training ground and launching point for the next giant leap, sending humans to Mars.
And a truly game-changing discovery is what makes this future seem possible. We used to think the moon was bone dry, but now we know there are significant deposits of water ice in permanently shadowed craters at the poles. This is huge. Water can be used for drinking, for breathing, and it can be split into hydrogen and oxygen for rocket fuel.
Which brings us to our final big thought. For all of human history, the moon was a symbol of the unreachable. In the 20th century, we proved we could visit. Now, with the knowledge we have, the question for the 21st century is completely different. We've walked there, but could we one day live there? And what would that mean for the future of humanity? That's what we'll be watching for. Thanks for joining The Explainer.